when a massive ice wall over 1,100 feet tall collapsed in 2017. It exposed something that had been locked away since before human civilization existed. Scientists rushed to the site, and what they discovered in those dark, frozen depths was beyond anything they imagined. Today we're diving into one of the most significant discoveries in modern Antarctic research: 120-year sealed door found in Antarctica's ice wall. A hidden ecosystem that survived in conditions that should make life impossible. Bacterial mats creating underwater cities of light, and creatures with DNA that doesn't match anything else on Earth. In July 2017, satellite footage captured a wall of ice taller than the Empire State Building simply vanished. The Larsen C ice shelf, a fortress that had protected Antarctica's deepest secrets for over 120,000 years, broke apart in a matter of hours. A trillion tons of ice, an area 4 times larger than London, just floated away into the Southern Ocean. Scientists had been monitoring cracks in the ice for months. The iceberg that broke away was designated A68, and it was massive. When that ice wall collapsed, it exposed underwater landscapes that hadn't been touched by sunlight since the last ice age. Ancient seabeds, buried mountain ranges, and valleys deeper than the Grand Canyon suddenly became accessible to human exploration for the first time in over 100,000 years. These newly exposed areas were changing by the hour as warm water continued to flood in. Whatever secrets lay hidden beneath the ice, they had to document them fast before the environment transformed completely. The team deployed underwater robots equipped with cameras and sensors into the caverns beneath the collapsed ice. In the pitch-black depths where no sunlight had penetrated for over 120,000 years, life was thriving. When scientists such as those from the British Antarctic Survey eventually filmed the seafloor, they found a distinct ecosystem, but it consisted mostly of stationary filter feeders. They discovered flourishing communities of sponges, brittle stars, sea cucumbers, and bacterial mats. The waters beneath Antarctic ice shelves are generally oxygen-rich. The Antarctic bottom water is a deep, cold, and oxygenated current that circulates through these depths. The answer lay in the bedrock beneath them. Methane was seeping up from cracks in the seafloor, creating underwater oases where life clustered in impossible abundance. The gas provided fuel for bacteria, which formed the base of an entire ecosystem that had never been touched by solar energy. The actual surprise for scientists at Larsen C was the stillness and scarcity. They found a community of stationary animals, stalked sponges that had managed to survive on almost zero food for thousands of years, living life in slow motion. DNA analysis of the specimens revealed something even more shocking. These organisms weren't just adapted to extreme conditions. They were genetically distinct from anything else on the planet. The bacterial communities were particularly stunning. They'd formed complex structures that looked like underwater cities. Towering spires of living organisms created their own microenvironments. Where are you watching this video from? Comment below and share your thoughts about Antarctica. As the underwater robots pushed deeper into the newly exposed caverns, the first sonar readings came back, and the research team thought their equipment was malfunctioning. The data showed valleys carved into the bedrock that plunged over 7,000 feet below sea level. That's deeper than the Grand Canyon. Antarctica had been hiding a landscape more dramatic than anything on the surface of the continent. Ancient riverbeds snaked across the sea floor in perfect preservation. The last time water flowed through these channels, woolly mammoths were still roaming the earth. The mapping revealed mountain ranges that had been completely buried under miles of ice for millions of years. Peaks that would rival the Alps, hidden beneath Antarctica's frozen surface, like some lost world from a science fiction novel. The topographic data showed ridges, valleys, and plateaus that created a landscape more complex than Switzerland. The coastline we thought we knew doesn't even exist. The real edge of Antarctica, the actual bedrock boundary, sits hundreds of miles inland from where we'd drawn it on our maps. The coast we'd been looking at was just the edge of the ice sheet. The true Antarctic continent extends much further into what we thought was ocean. They found carved bedrock formations that looked like they'd been sculpted by flowing water. Smooth channels, polished stone surfaces, and carved basins that showed clear evidence of massive water flow. Water had rushed through these valleys with enough force to carve solid rock, creating underwater canyons that dwarfed anything visible on the surface. The preservation was incredible. It was like discovering a frozen moment in Earth's geological history, preserved in perfect detail for over 120,000 years. This is the time we have together today, so thank you for watching this video. If you enjoyed it and found it helpful, don't forget to like it, and if you're watching on your phone, be sure to hit the hype button below. As researchers pushed deeper into the newly exposed caverns, they started finding evidence of Antarctica's impossible past. Fossilized tree trunks, perfectly preserved in the ice, told a story that defied everything we thought we knew about the continent. We're talking about massive temperate forest trees, oak, beech, and pine species that belonged in places like North America or Europe. The preservation was so complete that scientists could still see the tree rings, count the seasons, and analyze the growth patterns. These forests had thrived in Antarctica when the continent was positioned much closer to the equator, before the slow drift of plate tectonics carried it to the bottom of the world. Leaf fossils showed intricate detail down to the cellular level, ferns with fronds the size of dinner tables, flowering plants that belonged in tropical rainforests. The ice had created a time capsule that preserved an entire ecosystem in perfect detail for millions of years. Some of these specimens were found in layers that suggested rapid burial, not the gradual accumulation of sediment over thousands of years, but catastrophic events that had buried entire forests almost instantly. Pollen samples revealed seasonal patterns that painted a picture of Antarctica's ancient climate: warm summers, mild winters, and rainfall patterns that supported lush vegetation across the entire continent. The data showed periods of dramatic change that transformed the landscape in geological moments. Ancient riverbeds contained sediments that told stories of massive flooding events. The geological evidence suggested that Antarctica had experienced periods where ice sheets melted completely, creating inland seas and river systems that dwarfed anything on the modern continent. Preserved in the ice were also specimens that shouldn't exist according to our understanding of evolution and migration patterns. Plant species that showed genetic connections to flora found in South America, Africa, and Australia. Evidence of when these continents were connected as the supercontinent Gondwana. The time capsule effect of ice preservation had created a museum of Earth's history that spanned millions of years. This video is directly connected to fascinating facts and untold stories about Antarctica. You can find the link in the description below or in the card showing on your screen right now. The discoveries beneath the collapsed ice walls aren't just fascinating glimpses into Antarctica's past. They're fundamentally changing how we understand our planet's future. The climate models that scientists use to predict global warming were built on assumptions about how ice sheets behave. But the evidence from beneath the collapsed ice walls shows that these massive frozen barriers can disappear far more quickly than anyone predicted. The Thwaites Glacier, already nicknamed the Doomsday Glacier by researchers, is showing the same stress fractures that preceded the Larsen C collapse. Here's the terrifying part. Thwaites alone contains enough ice to raise global sea levels by over 2 feet. But it's not just about the ice in Thwaites itself. This glacier acts like a cork in a bottle, holding back a much larger ice sheet that contains enough frozen water to raise sea levels by over 10 feet. If Thwaites goes, it could trigger a domino effect that would be catastrophic for coastal cities around the world. The newly exposed landscapes are revealing how this process unfolds. Warm ocean water is flooding into caverns beneath the ice, melting the glaciers from below at rates that make surface melting look insignificant. The ancient riverbeds and carved valleys show that this has happened before, and when it does, the changes are rapid and irreversible. Antarctica wasn't always frozen. For hundreds of millions of years, it was a warm green continent teeming with life. The transition from that world to the frozen wasteland we see today happened faster than most people realize. But the discoveries also offer hope for understanding life's resilience. The thriving ecosystems found in the pitch-black depths prove that life can adapt to conditions far more extreme than we ever imagined. As our planet changes, these findings expand our understanding of where and how life might survive. The creatures living in complete darkness beneath Antarctic ice have developed survival strategies that could teach us valuable lessons about adaptation and resilience. Scientists estimate they have maybe a decade to fully explore and catalog these environments before they're transformed beyond recognition. Every month brings new ice shelf collapses, exposing more hidden landscapes that begin changing immediately once they're flooded with warm water. The race to document these discoveries has become urgent. The secrets emerging from beneath Antarctica's ice are forcing us to confront an uncomfortable truth about our planet's climate system. The ice walls that collapsed weren't just barriers protecting ancient landscapes. They were barriers protecting us from understanding how quickly our world can change. What happens next depends on how fast we can learn from these revelations and adapt to a planet that's already in the process of dramatic transformation. Jupiter's moon Europa is covered by a thick shell of ice, beneath which scientists believe exists a vast liquid ocean. Saturn's moon Enceladus shows similar characteristics, with geysers of water vapor erupting from cracks in its icy surface. For years, these moons have been considered prime candidates in the search for extraterrestrial life. The discoveries beneath Antarctica's ice have transformed these from theoretical possibilities into genuine probabilities. The life forms found in Lake Vostok and beneath the collapsed ice shelves survive using chemosynthesis rather than photosynthesis. They derive energy from chemical reactions involving methane and other compounds seeping from the Earth's interior. This same process could be occurring in the subsurface oceans of Europa and Enceladus. The geological activity on these moons could provide the chemical energy needed to support entire ecosystems, just like we've found beneath Antarctic ice. NASA and other space agencies are now using Antarctica as a testing ground for missions to these icy moons. The techniques developed to drill through kilometers of Antarctic ice and explore the hidden world beneath are the same techniques that will one day be used to search for life on Europa. The underwater robots deployed in Antarctic subglacial lakes are prototypes for the vehicles that will one day swim through alien oceans light years away from Earth. The discovery of complex life forms like the amphipods found in the subglacial river beneath the Ross Ice Shelf was particularly significant. Scientists didn't expect to find anything more than simple bacteria in these isolated environments. Finding shrimp-like creatures thriving in complete darkness 500 meters beneath the ice, 500 kilometers away from the nearest sunlight, fundamentally changed the equation for where we should be looking for life in the universe. Despite everything we've discovered, we've barely scratched the surface of what's hidden beneath Antarctica's ice. The continent is larger than Europe, and we've only managed to directly observe a tiny fraction of what lies beneath. More than 90% of the continent beneath the ice remains unmapped and unknown. Every new discovery raises more questions than it answers. Scientists have detected a massive crater-like structure buried beneath the ice that could be the largest meteorite impact site ever discovered on Earth. If confirmed, the asteroid that created this crater would have been 4 to 5 times larger than the one that killed the dinosaurs. An impact of that magnitude could have contributed to the greatest mass extinction event in Earth's history, the Permian-Triassic extinction that wiped out over 80% of marine species and 70% of land vertebrates. The timeline matches up eerily well. The impact could have occurred somewhere between 100 and 500 million years ago, right around the time of the Great Dying. But we can't confirm this theory without drilling through kilometers of ice to take direct samples from the site. The Antarctic ice sheet has been hiding the potential cause of Earth's most catastrophic extinction event from us this entire time. Then there are the subglacial lakes. Scientists have discovered around 675 liquid lakes hidden beneath the Antarctic ice sheet, and we've only directly sampled a handful of them. Lake Vostok, the largest of these hidden lakes, is the 6th largest lake in the world by volume. It contains more water than Lake Michigan, and it's been completely sealed off from the outside world for at least 15 million years. When Russian researchers finally drilled down to Lake Vostok in 2012 and took water samples, they found evidence of unknown bacteria species. But the sample was contaminated, and the results remain controversial. What other life forms exist in Lake Vostok? What about the hundreds of other subglacial lakes we haven't even sampled yet? In 2020, researchers analyzing ice samples from near Lake Vostok found RNA sequences that were 97% similar to a species of rock codfish. This was the first scientific report suggesting that actual fish, not just bacteria, might be living in these isolated underground lakes. Imagine entire ecosystems of fish and other complex organisms that have been evolving in complete isolation beneath the ice for millions of years. The Gamburtsev mountain range, discovered in 1958, remains one of the most poorly studied mountain ranges on Earth. These mountains are roughly the same size as the Alps, with peaks reaching nearly 9,000 feet high, and they're completely buried beneath more than 2,000 feet of ice. We know they exist because of gravity measurements and radio echo sounding, but no human has ever actually seen them. What geological secrets do these mountains hold? What minerals or resources might be hidden within them? Every year, the Antarctic ice sheet loses more ice than it gains. The continent is changing faster than at any point in human history. The discoveries we've made beneath the collapsed ice walls are just the beginning. But time is running out to explore and document these hidden worlds before they're transformed forever. Climate change is accelerating the melting of Antarctic ice. The Thwaites Glacier is losing ice so rapidly that scientists estimate it could collapse within the next 50 years. When it does, it will expose vast new areas of the hidden world beneath the ice. But it will also trigger catastrophic sea level rise that will reshape coastlines around the globe. Cities like Miami, New York, Shanghai, and Mumbai could face existential threats from rising waters. The Antarctic Treaty, signed in 1959, has kept the continent preserved for scientific research and prevented any country from exploiting its resources. But that treaty comes up for review in 2048, just 24 years from now. Recent discoveries suggest that Antarctica may contain vast deposits of oil, natural gas, and valuable minerals. One Russian research vessel reportedly discovered an oil field in the Weddell Sea, containing an estimated 511 billion barrels of oil, roughly double the reserves of Saudi Arabia. The temptation to exploit these resources will be enormous. Countries like Argentina, Chile, the United Kingdom, Russia, and others all have territorial claims to parts of Antarctica. As the ice continues to melt and resources become more accessible, the pressure to abandon the Antarctic Treaty and begin drilling and mining operations will intensify. The pristine environments we've only just begun to discover could be destroyed before we even fully understand what's there. But there's another consideration. The life forms discovered beneath Antarctic ice could hold secrets that are invaluable to humanity. The bacteria that survive in extreme cold and darkness might contain compounds useful for medicine or biotechnology. The organisms that have evolved in isolation for millions of years represent unique branches of the tree of life that could teach us about evolution, adaptation, and survival. Destroying these ecosystems before we've studied them would be an irreplaceable loss to science. The hidden world beneath Antarctic ice is also our best laboratory for understanding how life might exist on other worlds. Every discovery we make beneath the ice informs our search for life on Europa, Enceladus, and other icy moons in our solar system. The techniques we develop for exploring subglacial lakes in Antarctica will be the same techniques we use to search for life in alien oceans. Preserving Antarctica's hidden ecosystems isn't just about protecting Earth's biodiversity. It's about advancing our understanding of life's possibilities throughout the universe. These discoveries remind us that our planet still holds mysteries we're only beginning to unravel. The life forms thriving beneath Antarctic ice prove that life can exist in conditions we once thought impossible, expanding our understanding of where to look for life beyond Earth. The ancient landscapes preserved beneath the ice tell us that our planet's climate can change far more rapidly than we realized, with implications for how we prepare for the future. But time is running out. As Antarctica's ice continues to melt, we're in a race to explore and document these hidden worlds before they're transformed forever. The decisions we make in the coming decades about how to protect or exploit Antarctica will determine whether future generations inherit a pristine scientific laboratory or a plundered wasteland. The hidden world beneath Antarctic ice isn't just a curiosity, it's a window into Earth's past, a laboratory for understanding life's possibilities, and a warning about how quickly our world can change. What other secrets are waiting beneath the ice? What will we find as more barriers collapse and more of Antarctica's hidden world is revealed? What do you think is the most fascinating discovery beneath Antarctic ice? If you found this journey into Antarctica's hidden world as fascinating as I did, make sure to hit that like button and subscribe to the channel. We're constantly exploring the mysteries of our planet and beyond, and you won't want to miss what we uncover next. Click the bell icon to get notified whenever we post a new video. Thanks for watching, and I'll see you in the next one. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.